Now, the next thing that we are going to look at is actually the process of encoding the other non-zero coefficients. The other non-zero coefficients referred to as levels in the standard. Remember, this is very important. When we actually speak about non-zero coefficient, we speak about those coefficients that are greater than zero. It's clear from referencing to them. And we said non-zero coefficients are composed of two types. There are two types of those non-zero coefficients. It's those that will be separately encoded as trailing ones, and we explained what are trailing ones, and we have also explained how to encode those non-zero coefficients as trailing ones. And then we have those non-zero coefficients that are not part of the trailing ones. They are encoded separately and they are referred to as levels. Does that make sense? So the process of encoding these two types of non-zero coefficient, it's slightly different. And we have explained the trailing ones, how to encode them. And this is the code that we got after we have encoded the number of non-zero coefficient in this block and the trailing one. So this is the bit stream. This is how a bit stream looks like after we have encoded. We've encoded the number of non-zero coefficients and the trailing ones. This is how a bit stream would look like. So the next thing that we are going to do now is to encode the levels, the other two non-zero coefficients, which is -1 and 3 in this case. Zeros, we don't encode them, and that is how we actually save the space. Does that make sense? We don't encode zeros. We just encode the non-zero coefficients, and then we also encode the position where they are in the block. Does that make sense? So let's look at how to encode these the levels now. We are encoding levels, right? We said the process of encoding levels is composed overall of 15. There are 15 steps. So you're not going to use all those 15 steps for each and every level that you encode. It will just depend on certain metrics, such as the value of that level that you are trying to encode. Does that make sense? And the position where you are in your encoding process. Does that make sense? So here, the processes that we are going to look at, and I'm going to show you those processes and explain them and put them on the screen. The processes that we are going to look at, it's step number 1. The process of encoding levels is composed of 15 steps, and the steps that we are going to look at to encode this block, it's step number 1, and you'll see why. It's step number 1 and step number 4, 5, 6, 7, 8, 9, 10 up until 15. Step number 1 and then step number 4 up until 15. It's only those steps that we are going to deal with to encode this block. And this is basically defined by what? By the values that are in there. For example, the values that are in there, the first level has a value that is less than 8. So if the value of that level, of the first level that we are going to encode was greater than 8, we would have taken other steps from this. But here we're going to focus on these ones because of that value. So that's what I'm saying, that you're not going to work with all those steps. You're going to work on certain steps depending on the value and the position where you are of your encoding. So the bit stream, to represent the value of each coefficient of each level, the bit stream to represent the value of each level that you are encoding is composed of 2 parts. For a level, when you are encoding levels, the bit stream to represent each level that you are encoding is composed of 2 parts. The prefix part, let's write it here, the prefix part and the suffix part. right? So how do you calculate this prefix and suffix part? Cool. That's what we are going to do. The prefix part is actually a series of zeros that are terminated by a 1. Ne? A series of zeros that are terminated by a 1. So how many zeros and how is that done? That's the question that I'm trying to answer. How do you calculate this prefix part? How do you calculate this prefix part? The value of the level that you are encoding has a role to play in that. But you must understand that the prefix part is composed of a series of zeros. It doesn't matter how many of them, and then it's terminated by 1. So how many zeros? How do you calculate the number of zeros that will precede this one for your prefix part? Right, that's what we are looking at. Now, we say the suffix part is going to be a series of ones and zeros, or let's say the suffix part is going to be also contain a bit that will define the sign of the level that you are trying to encode. If it's negative, there's a bit that is going to tell you in the bit stream of the suffix part that is going to tell you that level that you are encoding is negative, and if it's positive, there's a bit that you have to look to be able to determine, to actually be able to determine the sign of the level that you are encoding. There's a bit that you have to look, and that bit, it's the least significant bit of the suffix part. The suffix part, the least significant bit of the suffix part. We say the bit stream to encode your each level. Each level is composed of two parts, the prefix part, and we explain the prefix part is basically a series of zeros terminated by a 1. We're going to look at how do you calculate the number of zeros that will precede that 1 to make up your prefix. And then we said it also composed the other part of the bit stream to determine the level that you are trying to encode is a suffix part. And we say in the suffix part, the least significant bit of the suffix part of your bit stream defines the sign of that level that you are encoding. If you are encoding a negative level, then you are going to have a 1 as a least significant bit of the suffix part. And then if you are encoding a positive number, you are going to have a 0 as the least significant bit of the suffix part. Does that make sense? Right. So how do you calculate the remaining bits of the suffix part is what we're going to look at. So let's start with the suffix part, with this prefix part, before we come to this suffix part. The prefix part, we say it's actually a series of zeros that are terminated by 1. So how do you calculate those number of zeros? Here is how you do that. So here is how you get the prefix part, right? We look at step number 1 of this. It's going to be shown here. Let's look at step number 1 of encoding, right? It says, if this is an algorithm, this is a pseudocode of an algorithm to do the encoding. It says, if the number of coefficients, non-zero coefficients, is greater than 10 and the trailing ones is less than 3, you set the suffix length equals to 1, or else suffix length is equals to 0. So this is another component that is coming out. We've got what is called a suffix length, which is basically the number of bits of the suffix part of your bit stream that defines or that encodes your level. We said the level is composed of two parts, the suffix part and the prefix part, that are concatenated together, that are put side by side. So the first step says, okay, if your number of non-zero coefficients is greater than 10 and trailing ones is let me confirm here, and trailing ones is less than 3. Therefore, you set the suffix length to 1, right? So in this case, the number of coefficients, the number of non-zero coefficients that we have is not greater than 10, so that fails. So if this condition fails, it says set your suffix length to 0, which would be the case for most of the time. So we set suffix length, right, equals to 0, right? That's our suffix length. That's what we need to do for the first step. That's the first step, right? Cool. Now we're trying to calculate the prefix part of this level, and we're trying to encode this -1, right? Cool. So that's the first step. So it says, the step 2, it says if suffix length is equals to 0, which in this case it is equals to 0, and let's look at the other condition, and number of coefficients is less or equals to 3, or trailing ones is less than 3, change the value of value of a as an absolute value to absolute value a minus 1, right? So, but this condition does not pass, so that means we will not be doing this, right? Cool. So we go to the second, and sign is the same, so that means we keep the sign. Cool. Or else keep a as the same. So here, because this condition that we are being asked to perform this, if it is true, to do this, it's not passing, so we're going to keep our a, and the level that we are is -1. So we keep a as is, because that's what the step is saying. We must keep a as is if the condition does not pass, right? So now we go to the third step. The third step, it says if the absolute value, which in this case is -1, if the absolute value of a, which is, this a refers to the level that you are encoding, if this absolute value is less than 8, now it says, it gives you the formula to calculate the number of zeros that precede your 0. That means it gives you the prefix part. Now listen, that is step number 3. If not step number 3, it's actually step number 1. It's actually sub-step number 1 of step number 2. If the absolute value of a is less than 8, there is no suffix. So it tells you that we don't have a suffix if the absolute value of the level that you are trying to encode is less than 8. There's no suffix, right? There is no suffix. Prefix will be found for, so we are going to only determine the prefix, and we said the prefix is actually a 1 that is preceded by a certain number of zeros. So how many of those zeros? So that is the case that we are trying. So it says the number of zeros, because if the step says if the absolute value of the level that you are trying to encode, in this case we are trying to encode -1, if the absolute value is less than 8, so therefore this is how you calculate your prefix. Your prefix is therefore equals to 2 multiplied by the absolute value of a, which is the level that you are encoding, -1, right, plus the sign. We set the sign will be a 1 to represent a positive, equals to a negative, I mean to say, and then a positive will be represented by a 0. Does that make sense? Right. So now let's look at this value. So here we are trying to encode -1. So we say 2 multiplied by the absolute value of -2 minus 1 plus the sign bit. The sign bit here is should be 1, because why? Because it's a negative number. If we were encoding a positive number, it was going to be 0. So the sign bit here is I don't think you see this. So the sign bit here is 1. We've put 1, right? Cool. So let's calculate this. 2 multiplied by 1 minus 1, which is 0 plus 1, right? And then this whole thing is going to give us, So this number actually gives us the number of zeros that precede A1. Does that make sense? So here that means we have 1, 0, we have 1 0 that precede A1. So that means in our bit stream, when we are now encoding, what we output to our bit stream here to encode this -1 is 0 0 1. Does that make sense? Because here we have 1 0 that precedes A1. So this 0 1 encodes that negative 1. So let's go to the next level and see how do we encode the next level. So the next step, so it says after this step, it says after you have encoded the first this level, you must go to step 13. So let's go and look at step 13. Based on present non-zero coefficient, which is A, set the next suffix according to table 3. So table 3, it's actually a table that defines, depending on the value of the level that we have encoded. So it depends on the value of the level that we have encoded. If the level has a certain threshold, we therefore need to increment our suffix length. But if that value does not reach a certain threshold, we therefore would not need to do our suffix length. And our suffix length, we said, it's actually the number of bits that are found in the suffix part of the level, right? The level, we said, is composed of two parts: the prefix part, which is what we are doing here, and the suffix part. And we said the suffix part, the least significant bit of the suffix part, defines the sign of the level that we are encoding. If it's negative, that least significant bit of the suffix part would be 1, and if we are encoding a positive level, the least significant bit of the suffix part of that level would be 0. Does that make sense? So now 13, now it says look at the value of the level that you have just encoded. In this case, it's 1. So it says if that level, let's say, if says, then change the values. So there are 3 things that you need to do there. If the non-zero coefficient is first non-zero coefficient other than trailing ones, if the present is greater than 3, then the new suffix length is equals to 3. So our level is not greater than 3, is -3. So we're not going to change our suffix length to 2. Else, if the new suffix length is equals to 2, that would have happened if we have changed it to equals to 2. In this case, it's not. It is still 0, remember. And the previous suffix length is equals to 0. Then suffix length is equals to new suffix length, which would be. So these are the steps that you need to follow. But here in this case, what we are going to do is that suffix length is just going to be incremented. Will be incremented, right? Will be incremented because it is less than a threshold of 3. 3 is the value that we're looking. If we had a level that was greater than 3, we were going to have to follow other steps. We're going to look at this in the code. I think it would be very much easier to explain it when you are looking at it on the code. But at the end here, the most important thing is that when you are encoding your levels, which are those non-zero coefficient in your block, when you're encoding that, there are 15 steps, and I'm going to give you all these steps. I have them here. I've written them, and you have those steps that you have to follow. If you go to the standard, unfortunately, you don't get these steps. They just give you a what should I call that? They just tell you how to decode in the standard. Remember, they don't tell you how to encode in the standard. They only give you like including code snippets of how to decode, and then they explain things on how to decode. They don't really tell the process of encoding. So in order to understand that decoding, especially on this part, from my own experience, is that it's important to actually go to the encoding part, because once you understand the other side, it's easy to actually understand the other side. If you know how to decode, you probably will know how to encode. But the issue may be that it may be easier to understand the encoding process depending on what you are dealing with at hand. Like for instance, in this case, we're dealing with encoding levels. I find it to be easier to understand the encoding part of it than the decoding part, because the decoding part of it is just a code that is in there. And hey, it was very difficult for me like to get around that code until I had to do a research and double check what exactly is going on there. Then I was able to actually come up with the encoding part. And once I understood the encoding part, it was very easier to even understand the decoding part. So here, I think it would be very much easier if we actually go to the code. So let's go to the code.